Let us discuss about the physical properties of aldehyde and ketones. Physical properties of aldehydes and ketones. So we'll discuss three main properties of aldehyde and ketones here. And the first one is the boiling point. And as you know, boiling point depends on the intermolecular forces of attractions. Depends on the intermolecular forces of attractions. And in aldehyde ketones and in aldehydes and ketones, the intermolecular forces of attraction are the dipole-dipole attractions. Dipole-dipole. Dipole-dipole attractions. And they both contains carbonyl group which is polar in nature, and we have a dipole. So that's why the intermolecular forces of attraction are the dipole-dipole attractions. And these dipole-dipole attractions, are stronger than the van der Waals forces present in alkanes, but weaker than hydrogen bonding present in alcohols. Hydrogen bonding present in alcohols. Therefore, the aldehyde and ketones have a higher boiling point than alkanes but lower than alcohols. So this is a boiling point order. Now, second point is that out of aldehyde and ketones, aldehydes and ketones, ketones are more polar due to the presence of two electron donating groups. As a result, the dipole-dipole attractions in ketones is stronger than the dipole-dipole attraction in aldehydes. And hence, ketones have a higher boiling point than aldehydes. So our boiling point order is this, that alkanes have the lowest boiling point because of the weak van der Waals forces. Then comes aldehydes, ketones, and the alcohols have the highest boiling point due to hydrogen bonding. So this is the boiling point order. Now, second point is the solubility. And remember, for any compound to be soluble in water, the compound should form hydrogen bonds with water. So, methanol, ethanol, propanol, and the propanone, acetone, are completely miscible in water. As they are capable of forming hydrogen bonds with water through carbonyl oxygen. With water through carbonyl oxygen. Like this. This is methanol, and it can form hydrogen bonds with water through this carbonyl oxygen, and hence it is completely miscible in water. Acetone is also completely miscible in water. Completely miscible in water. But acetophenone, this is called acetophenone, benzophenone, diphenyl ketone, which is also known as diphenyl ketone, are immiscible in water. Means they cannot form hydrogen bonds with water due to the presence of bulky, non-polar, hydrophobic benzene rings. So they keep the water away, and hence they are immiscible in water. Now the third is the reactivity of carbonyl group, reactivity of aldehyde and ketones. Aldehydes and ketones. This is a very, very important point. Now aldehyde and ketones, they both contains carbonyl group, and this carbonyl group is unsaturated but polar. There is a charge separation. Carbon is partial positive and oxygen is partial negative. So the main reactions are addition reactions. And since carbon is positively charged, nucleophile adds to the carbonyl carbon, and electrophile adds to oxygen, adds to carbonyl oxygen. Therefore, the reactions are called nucleophilic addition reactions, since nucleophile adds to the carbonyl carbon. Nucleophilic addition reactions. And for the nucleophile to attack, the carbonyl carbon should be more and more positively charged. Electron density at the carbonyl carbon should be as low as possible. So the reactivity of carbonyl compound or carbonyl group is inversely proportional to the electron density at the carbonyl carbon. Now for the nucleophile to attack, the carbonyl carbon should be less crowded, so that nucleophile can easily attack at the carbonyl carbon. So more the crowding, more difficult for the nucleophile to attack, and as a result the reactivity will be less. So the reactivity of the carbonyl group is inversely proportional to the crowding at the carbonyl carbon. This factor is also known as a steric effect. Crowding at the carbonyl carbon. So these 2 points are very, very important. This is called electronic factor and this is called the steric factor. This is called electronic factor and this is called the steric effect or steric factor. Now, due to the presence of two electron donating alkyl groups, the ketone carbon is more electron rich, more crowded, so more difficult for nucleophile to attack, more difficult for the nucleophile to attack at the ketone carbon, then aldehydes, and hence ketones are less reactive than aldehydes. For example, this is the most reactive aldehyde. Then comes CH3CHO. Then comes propanol. Then comes acetone. And then comes, this is called pentanone 3. So this is the reactivity order towards the nucleophilic addition reaction. Now, aromatic aldehyde and ketones. Aromatic aldehydes and ketones are less reactive than aliphatic aldehyde and ketones, are less reactive than aliphatic aldehydes and ketones are due to first factor, the crowding at the carbonyl carbon, and the second is the positive charge of the carbonyl carbon is delocalized, means participates into resonance, delocalized with the benzene ring, like this. This may be aldehyde, may be ketone, and once this acquires a positive charge, the positive charge gets delocalized like this. Therefore, the aromatic aldehyde and ketones are less reactive than aliphatic aldehyde and ketones. Now, for example, this one is benzaldehyde is less reactive than acetone, but more reactive than acetophenone. So this is the increasing reactivity order. So this is about the physical properties of aldehydes and ketones.